Hi class, welcome to review for the periodic table test. As in all reviews, in bold we have the major understandings. These are the big ideas you should study before the test. After that, we have some practice questions. Let's get started in looking at some of the major understandings and the big ideas about how the periodic table is arranged and the major parts of it. Looking at the periodic table, you can notice that the elements are arranged in increasing atomic number. Now, important parts of the periodic table are labeled. So periods represent rows, and groups represent columns. Very important geographic location on the periodic table is the bold zigzag staircase. This bold zigzag staircase separates the metals, the nonmetals, and the metalloids. For the elements that touch the bold staircase on two sides, with the exception of aluminum, are called metalloids. Shaded in blue are the metalloids. Everything that falls to the left or under the staircase are metals, including these inner transition metals. And everything that's above or to the right of the stair steps, these are called nonmetals. When looking at our periodic table, we'll notice two interesting trends. The first trend being that all the elements in the same group tend to have the same number of valence electrons. Now when we look across the period, we'll see that the atomic number changes, but the number of principal energy levels, or the number of rings of electrons in the Bohr model, remains constant. Recall that metals have some unique properties. Metals tend to be shiny or have luster. They're malleable, which means they can be hammered into sheets. They're ductile, which means they can be pulled into wires. They're good conductors of heat and electricity, and they tend to form cations, or positively charged ions. Versus nonmetals, they don't tend to have luster, they tend to be dull. Most of their solids are brittle, meaning they kind of crumble, though many of them are liquids or gases at room temperature. They're very poor conductors of heat or electricity. They tend to be insulators. And they tend to form negatively charged ions called anions. Now, of course, there's a third category here. There are the metalloids. And the metalloids are unique because under certain conditions they can have properties of both metals and nonmetals. Now, there are a couple important families. Now, family refers to groups on the periodic table that we must be familiar with. The families that we must be familiar with are group 1. These are called the alkali metals. The alkali metals, the word alkali means base, so they produce base when they react with water. These metals tend to react quite violently with water as their reactivity increases as we go down the periodic table. Metals want to lose electrons, so the best losers of electrons are the biggest atoms with the lowest first ionization energies and lowest electronegativities. So francium is the most reactive metal. Now, group number 2 are called the alkaline earth metals. The alkaline earth metals also produce base when reacting with water, though the base is less caustic or less strong. The reaction is less severe than that of the alkaline metals. Moving on towards the right, we have the transition metals, which include these inner transition metals also. These transition metals are unique because they have multiple valence, they have multiple oxidation states, and their oxidation states are found in the upper right-hand corner of your reference table. The transition metals are unique because they tend to form colored ions in solution. So we can see that iron is a transition metal. So our reason our blood is red and it's not colorless like seawater is that it has a transition metal, iron, in it. The next important family are the halogens. The halogens consist of nonmetals, and they are highly reactive nonmetals. Now, nonmetals have chemical behavior exactly opposite that of metals. So the most active nonmetal will be the element that has the best ability to gain electrons. Therefore, it would have a very high first ionization energy and a very high electronegativity. So the most active nonmetal is actually fluorine. And our final group of elements that we're going to look at are the noble gases. The noble gases are the kings, the nobility of the periodic table. They have extremely stable electron configurations because they have full valence shells, or complete valence shells is a better term. Complete valence shells are 2 for hydrogen and 8 for the rest of them. So basically we can think that 8 is great, but 2 will do for the noble gases. So when atoms form ions, they gain or lose electrons, and the entire purpose of gaining or losing electrons is to have the same stable noble gas electron configuration as any of the noble gases. So we have approximately 120 elements, and when they form ions, they mimic the electron configuration of these 7 elements. So that's pretty amazing. So as we start our review of the basic makeup of the periodic table, we can see in this question, number 1, that it asks, to determine the order of placement of elements on the modern periodic table, they are arranged by atomic number. Now, they're not arranged by the number of neutrons, as they can vary by isotope, and so that eliminates choice 3 and 4. Now, when we look at our periodic table, we want to make sure that we understand that we're also not by atomic mass. Though many of the elements are arranged in sequential atomic mass, there are a few exceptions. Let's take a look. So here we have a blow-up of the periodic table to look at one of the places where mass does not increase across the periodic table. So when we look at cobalt element 27, we see that the mass is 58.9. But when we look at nickel, the next element, it's only 58.6. So mass doesn't always increase as we move across the periodic table or from elements of increasing atomic number. The atomic number always increases by 1. And in general, the mass does increase, but there are a few exceptions, like I noted. The next question asks us about germanium. So when you're given an element name on the periodic table, it is very possible that you won't know what the element symbol is. For this, we're going to have to use reference table S. Looking at reference table S, we can find germanium is element number 32. So now we need to refer back to our reference table and find element number 32. Here we find germanium element number 32. Notice that germanium has 2 sides of the bolded staircase or zigzag touching it. That makes germanium a metalloid. Know that germanium is a metalloid. Next it asks, which symbol represent a metalloid and a noble gas? let's look back at our periodic table. So recall that metalloids are the elements that border this bolded staircase by two sides. So these are going to be our metalloids here. Okay, now and our noble gases are going to be the elements found in the group 18. So these are the noble gases. So we're looking for elements that fall in these two categories. So argon and arsenic are both a metalloid and a noble gas. Now the next question asks, based on the periodic table, explain why sodium and potassium have similar chemical properties. So when we examine this question, we want to pay very careful attention to the based on the periodic table, meaning look at the periodic table and explain what you can see that is similar between sodium and potassium. So here we're asked to look at sodium and potassium. We can see they have different atomic numbers of 11 and 19. They have different masses. But what is the same is found in the upper right-hand corner of your periodic table. Their oxidation number, and what else is the same is found down in the electron configuration, their valence number. So if we forget what these things are, we can look here and we can look here. So let's go back to the question. The next question asks us to find which is a solid at STP. To find this is review, we are going to have to use reference table S. And we're going to have to look at melting points and boiling points. Here we are asked to evaluate the state of matter at STP for hydrogen, number 1, nitrogen, number 7, fluorine, number 9, and iodine, number 53. Now, number 53 will be on a separate table. I'll simply add it here. Recall that in order to figure out the state of matter at STP, we have to know what STP is. That is found on reference table A to be 273 Kelvin. And we're going to create a number line using the melting point and boiling point and the number 273. If on our number line 273 falls before the melting point and boiling point, we'll have a solid. If it falls in between the melting point and boiling point, we have a liquid. And if it falls after, we'll have a gas. So looking at hydrogen, its melting point is 14 and its boiling point is 200. The boiling point is 20. So the number 273 would fall somewhere towards the to the right of both of these in the number line. So if this was a number line, we would have the number 273 fall over here. So that means hydrogen is a gas. Now when we look at oxygen, we have 54 and 90. So 273 again falls over here. Question number 6 asks us to find properties of most non-metal solids. So we know that non-metals are poor conductors. They're actually insulators. So these high conductors are eliminated. And non-metals are not malleable. Metals are malleable. So non-metals are brittle. They tend to fall apart. The next question asks us to evaluate both diamond and graphite. And we know that both diamond and graphite are pure carbon solids. So they have the same chemical formula. So, but diamonds are very hard and a very hard material, crystalline material. And graphite, which is pencil lead, is a really soft material. So that means that they have different structures, different shapes in which they arrange themselves. Diamonds arrange themselves in a very geometric, tight-knit pattern, whereas graphite arranges itself in planes so that one plane of graphite can slide off. So that's how a pencil works. So they will have different chemical and different molecular and structure and properties. And notice how when we look at the next question, very similar, we're asked about oxygen and ozone and how they differ. And their atoms, oxygen, are actually the same, but their molecules have different shapes and therefore different properties. So notice how the answers are very similar here. Remember that questions on the regions tend to repeat themselves and have very similar answers.